Space is vast. It is filled with wonder and beauty, but it also holds dangers. Asteroids, remnants of our solar system's formation, hurtle through the darkness. Most are harmless, their paths far from Earth. However, some stray close, reminding us of the cosmos's raw power. These cosmic wanderers capable of reshaping worlds pique our scientific curiosity and ignite our primal fears. For millennia, humans have gazed at the night sky, tracking the movements of stars and planets. We have learned to predict their courses, understanding the celestial dance of our solar system. Yet the universe remains full of surprises. Asteroids, often unseen until they are upon us, remind us of our vulnerability. They are a cosmic wildcard, capable of disrupting the delicate balance of life on Earth. In 1908, a relatively small asteroid, perhaps only 100 feet wide, exploded over Tunguska, Siberia. The blast, estimated to be thousands of times more powerful than the Hiroshima bomb, flattened trees over an area twice the size of London. The Tunguska event served as a stark reminder. Space can be a beautiful, awe-inspiring place, but it can also be indifferent to our existence. Today we stand on the cusp of new discoveries, constantly refining our understanding of the cosmos. We are developing technologies to track and potentially deflect asteroids, but the task remains daunting. The universe is vast and our knowledge is still evolving. On December 27, 2024, astronomers made a startling discovery. A new asteroid, designated 2024 YR4, was on a trajectory that brought it unnervingly close to Earth. Initial observations were limited, but they revealed a chilling fact. 2024 YR4 was no ordinary space rock. Its size, estimated to be between 40 and 90 meters wide, placed it in a category of asteroids capable of causing significant damage if they were to collide with Earth. The significance of 2024 YR4's size cannot be overstated. While smaller asteroids might burn up in the atmosphere or cause localized damage, an object of this scale could devastate a city-sized area upon impact. The energy released would be equivalent to hundreds of Hiroshima bombs, creating widespread destruction and potentially throwing our planet's climate into disarray. The discovery of 2024 YR4 sent ripples of concern through the scientific community. It became a top priority for observation and analysis. Astronomers around the world aimed their telescopes towards this newly discovered celestial neighbor, eager to gather as much data as possible. The race was on to determine the likelihood of an impact and, more importantly, what we could do to prevent a potential catastrophe. On February 7, 2025, after weeks of anticipation, the first images of asteroid 2024 YR4 were released to the public. Captured by the Gemini South Telescope in Chile, these images, though grainy and indistinct, represented a significant breakthrough in our understanding of this potential threat. They offered the first real glimpse of this celestial object that had captured the world's attention. The images, while not visually spectacular, were a testament to the ingenuity and perseverance of the astronomers involved. Capturing a faint, rapidly moving object millions of miles away is no easy feat. It requires sophisticated equipment, precise calculations, and a healthy dose of luck. The fact that these images were captured at all is a testament to the capabilities of modern astronomy. More important than their aesthetic appeal was the data these images contained. By analyzing the light reflected from 2024 YR4, scientists could begin to glean vital information about its composition, rotation, and trajectory. This data is crucial for refining our understanding of the asteroid's orbit and ultimately determining the likelihood of an impact with Earth. Section 4. Mapping the Danger Zones, a Global Perspective. As scientists continued to track 2024 YR4's trajectory, a chilling picture began to emerge. The asteroid's path intersected with Earth's orbit, creating a risk corridor that spanned a significant portion of the globe. This corridor, stretching across the eastern Pacific Ocean, northern South America, the Atlantic Africa, the Arabian Sea and South Asia, represented the areas on Earth most likely to be impacted should 2024 YR4 stay on its current course. The publication of this risk corridor, while based on the best available data, sent a wave of anxiety across the world. The vastness of the corridor, encompassing multiple continents and countless population centers, underscored the potential global impact of such an event. The possibility of a city-destroying asteroid striking Earth, once a topic relegated to science fiction, was suddenly a sobering reality. It is important to note, however, that the risk corridor represents a range of possibilities, not a definitive prediction of where 2024 YR4 will ultimately travel. The asteroid's orbit is constantly being refined as new data becomes available. Furthermore, even within the risk corridor, the vast majority of the Earth's surface is uninhabited, making a direct impact on a populated area statistically unlikely. Section 5, Deflecting Disaster. Can we dodge a cosmic bullet? The discovery of 2024 YR4 has reignited the debate about humanity's ability to protect itself from cosmic threats. While the possibility of an asteroid impact might seem like the stuff of disaster movies, it is a very real threat that we must be prepared to address. The question is, what can we do to prevent such a catastrophe? Fortunately, scientists and engineers have been working on potential solutions for years. One promising approach is kinetic impact, which involves slamming a spacecraft into the asteroid to alter its trajectory. This technique was successfully demonstrated by NASA's DART mission in 2022, when it successfully altered the course of a small asteroid moonlet. However, deflecting an asteroid the size of 2024 YR4 presents unique challenges. The sheer mass of the object means that a much larger impactor would be required, and even then, success is not guaranteed. Additionally, the composition and structure of the asteroid are still unknown, which could affect the effectiveness of any deflection attempt. Another potential solution is the use of a gravity tractor, a spacecraft that would use its own gravitational pull to slowly nudge the asteroid off course. This method, while theoretically sound, would require years, if not decades, of lead time to be effective.